Is 3D printing good for the planet? How does it enable circularity? Welcome to the Circular Future, showcasing stories of circularity that reshaped how businesses operate and how you can do it too. I'm your host, Stephanie McLarty, Head of Sustainability at Quantum Lifecycle Partners, your trusted partner in electronics circularity. I love today's conversation. It's all about 3D printing, which, as we learn, is also called additive manufacturing. I don't know about you, but I've never 3D printed anything before, and I had preconceptions of how it worked and what it could do. So if anything, this episode is about myth busting. Our guest is Steve Cory from Objex Unlimited, a longtime leader in 3D printing. He's very frank about how 3D printing helps the environment, but also the darker side to it and what needs to be done to manage the environmental footprint. It's a fun and fascinating conversation. We'll get started after this short message. Apparently, only sustainability pros read sustainability reports? Well, consider this your invitation to crash the party. Peek at Quantum Lifecycle's report and see how we're leading the charge at quantumlifecycle.com/sustainability. Welcome to the podcast, Steve.
Thanks, Steph. It's great to be here. I'm really excited to work with Quantum Lifecycle Partners and really understand a little bit how to really manage our waste in a responsible manner.
Oh, awesome. We are delighted to work with you, Steve, at Objex. And I actually really like this example of how we work with you on your big 3D printing machines, and that it's not the everyday tech that people think of, that there's just stuff out there that needs to be recycled. But we'll get into that. Let's start with the very first question we ask everyone. Steve, what would be 3 things that we wouldn't necessarily know about Objex Unlimited and what you do?
Sure. I mean, Objects Unlimited, we're a 3D printing company. We do printing and then we sell equipment as well. What you might not know about us, well, you know stuff because you've been here, but we're a pretty big place. We have lots of equipment. Many people think that we're a 3D printing shop, so we have maybe a couple small little desktop machines or maybe a print farm of all these little small machines, but Objects is quite different. We tend to focus on larger industrial machines for different kind of applications. The second thing that people probably don't know about us is we've been in business for quite a long time. This is our 15th year in the 3D printing world. Now people say, oh, so you were right at the very start of 3D printing. The first 3D printed part was in 1982. The technology took quite a while to mature. We started in 2011 with very different technology than we have today. And in fact, that's how we met Quantum Lifecycle, is trying to dispose of some of our older machines. The third thing that people don't know about Objex is we work in a bunch of different industries. We do mechanical parts, but we also do movie props. We help jewelers. We work in dentistry. We work with hospitals. We work with schools. There's so many different applications of the technology when you have the right skill set and the right equipment. So we do a lot of things that other people don't, and we're quite a different 3D printing company in that aspect.
Yeah, you mentioned us visiting you, and about a month ago, a couple colleagues and I visited Objex, and Steve, it totally blew my mind. I was so surprised. You have like so many big printing machines, the applications of what you do, it's just so vast. It really challenged my thinking of what 3D printing was and how it can be used. So let's get into that, because I really want to understand, is 3D printing good for the environment and how does it enable circularity? But I think first we need to unpack what 3D printing actually is. And you mentioned a whole bunch of industries that you work in. What are some of the examples of the applications of 3D printing in those industries?
Yeah, I think the first step back for people that aren't familiar with the technology is basically, we call it additive manufacturing. So in traditional manufacturing, you take a chunk of material and you remove what you don't need, or you're injecting something into a mold and exploding it. With 3D printing, we build things up layer by layer by layer. So It's really good for small production runs, for prototyping, and for really, really complex objects. So in the early days of 3D printing, the vast majority of parts we made were prototypes, industrial prototypes for equipment design or for those kind of things. But as the technology has evolved and as the skill sets have evolved across the world, 3D printing has had lots of different applications. So it's certainly still used for prototyping. We see applications in jewelry where we direct print wax as opposed to going through a mold making process. Applications in medicine for prosthetics and for implants. There are, I mean, so many applications in equipment repair and machine maintenance, as well as product development, which really is probably the area where additive manufacturing or 3D printing can contribute the most to circularity. Now, I know in our shop and in every 3D printing shop, we do create a lot of waste. I generate a lot of burned out prints or support material that we're tearing off the part and throwing away. So yes, there is a lot of waste. It appears. However, if you ever go to a traditional manufacturing facility and you see the amount of waste that's generated, it can be quite efficient, but the amount of waste that we generate per dollar of revenue is probably pretty low compared to some other industries. Um, but I do think there's some huge advantages to 3D printing from an environmental perspective. And it goes back to product development. So what 3D printing has allowed us to do is iterate designs faster. So in the old days, when I was in the machining world, a prototype was 16 weeks or 18 weeks to make one. Well, now we can do it in 5 or 6 hours, and pretty much many companies have desktop 3D printers on their desk because they're so accessible now. So when you iterate design, when you make a product once, twice, 3 times, your third design is pretty much always better than your first design. Your 15th design is usually better than your third design. There becomes a point of diminishing return, but the more that you iterate your design, the more you can get a really good product. And the key in a lot of product development is weight. So when you're producing any part whatsoever, it doesn't matter what method that you use, the lower the weight of the part, the less material you tend to use, but more importantly, the lower the shipping cost. So if you
Mm,
think about a product that's been developed and someone used additive manufacturing and they created 10 pounds of waste to finish their prototyping, to really feel how to make their end part, and that end part saves 10 grams, and then they make a million of them. The amount of waste that saves, 10 grams times a million, the amount of shipping or emissions due to shipping that saves because of reduced weight. This is where I think additive manufacturing really contributes to sustainability and circularity. At first glance, it can seem like we're all making a bunch of toys and a bunch of useless stuff, which yes, that's how people learn the technology. But once you apply it, there's things we can make that you couldn't make otherwise. But I do feel the ability to produce a better design, which ultimately reduces weight, can save an awful lot of material.
right. So, okay, so additive manufacturing is another term for 3D printing. Is that right?
Correct,
So
because we're adding layers by layer. We're only using
interesting.
the material that we need. In some cases, we'll put a supporting material to hold empty space, but if you have so as a good example, one of the good applications for 3D printing is in aerospace. So if you have a curving titanium component that you're machining out of a block of cast titanium, you're wasting an incredible amount of metal. With machining, it's really hard to do latticing and to do other kind of weight saving tricks. With 3D printing, we're not as worried about curves or about getting machine tools into certain places. So we can use
Hmm.
different designs that use significantly less weight and can actually add significant strength as well. Again, in aerospace, it's very important because every pound of a weight increases your fuel usage. And so if you can take a component that weighs 5 pounds and make it 2 pounds, and you multiply that across 6 or 7 or 8 components, massive reduction in fuel costs over time, in some cases.
Yeah, I'm so glad you brought up that example, Steve. That one really stuck out to me when we were walking through your facility around aircraft parts and how this rapid prototyping that 3D printing enables really saves that weight and like allows for innovative designs because like they're so huge. Yeah, I can really wrap my head around that example. The other one that really stuck with me, your application for the jewelry industry and how they can use 3D printing for the ring molds and how it ultimately allows for like cutting down gold losses. Can you explain that?
Well, yes and no. I think for jewelry, the real key is saving time. So, traditional jewelry manufacturing, you make a positive in some way, and if you're making more than one ring, you would make a mold, then you would make a wax positive, and then you go and you cast that. What 3D printing allows jewelers to do is print their waxes directly, so you can print 50 waxes at a time, all different sizes, if you like. When we were talking about gold loss, it had to do with different types of 3D printing technology. So there's one type of technology that uses lasers to cure a photosensitive resin. And in that case, we use support posts to hold the part off the plate. When we remove those posts, there's a lot of little nubs left on there. And that's where I was referring to gold loss. When we remove those nubs and then you cast that part, those nubs are there on the cast part of gold. And as they sand those, you get microscopic gold loss, but it adds up significantly over time. So the
Oh.
technology that we use is a jetting process where we spit wax onto a plate. We use a wax support material that melts away, and so there's no interface between the wax and the support wax. And it's 100% jeweler's wax, so it casts very easily. So it's a little bit helpful for them. Uh, Jewelry, dentistry, hearing aids. I mean, anything that's small, custom, and high value. That's where additive manufacturing really makes sense. Now, to be
Hmm.
very clear to anybody who watches this podcast, I don't make aerospace parts. Metal 3D printing is a whole nother story. See at Objects is to do a lot of full color organic shapes, but we do end up getting involved in lots of different projects, and we see a lot of things out there. Um, Metal additive is very interesting. There's some things you can do with 3D printing that you cannot do traditionally, or it just takes a really long time. It's exciting, it's interesting. You need a lot different skill set than I have to work in
Mm.
that industry for sure.
Mm. It's so interesting. The one other thing I wanted to ask you about, and it's something that I just would assume that 3D printing could do that could help with circularity, is print parts. Like if you need a part that, to fix something that's not readily available, is that something that 3D printing can do that actually can help the planet, or am I wrong?
Will help the planet. Yes. So I'm actually literally on my desk is this part. This is a part for a machine that's being repaired. 25 of them are being repaired. Can't get this. No way to get it. But we can 3D print it. It took a while to figure it out, but this will allow 24 machines to be repaired that maybe they'd have to find another way. Maybe they would go in the garbage. Maybe they wouldn't. So yes, it is neat for that. Having said that, word of caution to everybody, listen to this. We have many people show up here with broken parts from their coffee maker or from their car and ask us to 3D print it, and it's not that simple. So before you 3D print, you need a validated file, which means either 3D scanning and then iterating to make sure that your scan was right and that it fits, or you need a file that is already ready to go and has been previously validated. This is try 15 of this to make it fit exactly because it's quite a tight fit where this particular part goes.
And just for our listeners, what Steve is holding up is it's a little item about an inch wide and what 3 or 4 inches long,
Yeah,
with
and it's
a whole bunch
rubber.
of dots. He can bend it. I don't know what it is,
Well,
but
it
as
fits
he
into this
explains,
manifold. I don't know what it is either, but it fits into this manifold. It has to be tight and airtight and rubber. All these are very challenging things to do. And although there's a lot of really good desktop consumer grade equipment out there, it's not quite good enough for this particular application.
okay, all right. So it's to assume that you can just print parts to fix something. Well, it can be done in certain applications. It's not a widespread
And
use.
I'm
Is
not
what I'm
sure
hearing.
it makes sense. So when I first
Okay.
started in this industry, people would tell me, "Oh, so we're never going to buy parts again from overseas. We'll just make everything." And the common item we talk about is a wheel for your dishwasher. So if the rack in your dishwasher, the wheel breaks, that happens to all of us. Sure, I could 3D print one, but they're $3 for 10 of them, on Amazon or on Home Depot. So it doesn't make sense.
Mm.
And I often think of there's an episode of The Big Bang Theory where Howard gets a rapid prototype machine and they make a whistle. And the comment after he took it out of the machine was, "Congratulations, you just spent 4 hours making something that cost 50 cents." And that is very, very true. Traditional manufacturing for mass produced items is really, really efficient and effective. And using 3D printing is rarely the case. I will say now that over the years, the industry has changed a lot. There's a lot of really excellent desktop grade 3D printers, under $5,000, and many, many people have them. The missing link is still design. But, there are millions of people printing parts every day based on designs they pull from the internet for whatever use they might have. Some people use it to organize their toolboxes. Some people build storage caddies. Some people make toys for their kids. Some people, make art pieces, whatever it is. The thing that I've seen change a lot in this industry, aside from the accessibility of the technology, is the growth in the knowledge of design.
Mm.
So many young people are being taught design tools in public school and in high school and in university, where they're able to then use those skill sets to design parts for 3D printing.
Okay, interesting. So design is a real enabler, really, of 3D printing.
Well, it's
Okay,
critical, right? Nothing starts with
yeah,
it. It all starts with a design. If you don't have a good design, you can't make it. And if your design is poor, it's not going to work. And scanning things is great, but it's not magic. And you still have to spend some time in CAD systems. Yes.
yeah. Steve, this is why I love talking to you. It's so much more to think about than, the surface assumption. And I really appreciate that you're very forthright about that. And I also appreciate you've said you're happy to talk about the downsides of 3D printing for the planet, and be honest about that. So, Steve, what would you say are the downsides of 3D printing when it comes to the environment?
Well, I mean, a few things. So one is just the waste that we do generate. Certainly, you have to manage your waste properly. So we have some methods where we use water to wash our parts. That water can't go down the drain. It has to be captured and properly cleaned. Same with used resins. Isopropyl alcohol has to be recycled properly. I would say it's not always done well by everybody. Not trying to insult anybody, but proper management of waste is important. I certainly, this weekend we had several print failures, and I probably created 30 pounds of ABS waste. Because for whatever reason, in this case, it was me not setting the part up properly. Yes, that goes in the garbage, and we have to reiterate. So we do create some waste, but having worked in a lot of industrial places in my lifetime, you've seen the size of our facility, and our garbage gets emptied once every 2 weeks. So is it that much waste? I mean, probably not. Certainly, the reason that we started working with Quantum is I had several like large 3D printers that I really didn't know what to do with. They all are full of circuit boards and wires and all kinds of electronics. And in the past, we basically stripped out what we wanted and then let them rot in the back parking lot until we decide to haul it to a landfill, and that is not ideal. And so the printers that we are recycling with Quantum Lifecycle are going to be stripped, properly recycled in Canada, not sent to some junkyard overseas in a developing country. Um, the metal will be recycled, the circuit boards will be recycled, it'll be done safely and properly. And that's a really good thing. And I think one of the important things about this podcast, and for people, if you're in my situation where you run industrial 3D printers and especially larger ones, it's really hard to get rid of them. It's really hard to get rid of them. Some people just pay someone to haul them away. Sometimes people donate them to schools, which is a really bad thing. Don't donate a not working printer to a school or a printer that the life cycle has run out. Um, and so I'm hoping that, there's a lot of 3D printing activity happening in the Toronto area and around North America, but I'm hoping other people realize there is a way to dispose of this stuff, and it's really, really inexpensive. Way less costly for me than hauling things to a landfill, and we sleep better at night for sure.
Yes, for sure. And thank you, Steve, for saying that, because anything with a battery or a plug, anything electronic, should not go in the landfill. It should be recycled responsibly, like Quantum, or another responsible recycler. And that's really key for our planet and our society. So thank
Oh,
you.
and it's interesting when the printer was picked up here, we actually did a little collection among all the staff to get all of our old stuff with a plug or a battery, and had a couple other boxes of miscellaneous, junk that I mean, we all like to be responsible, but I can't say we always are in disposing of our electronics. So it's really nice. I really didn't know that Quantum Lifecycle Partners existed until I started Googling how to recycle my machines. But it's really nice to know that that service exists and that it's done right. I
Hmm.
think that's the key, that it's done right and safely and here.
Yeah. Thank you, Steve. I wanted to ask you about the inks and basically the input that goes into 3D printing and how good for the environment that is, and if there's environmentally preferable options that way.
Well, I don't think any inks are good for the environment. We use lots of different types of materials. So sometimes we'll use filaments or pellets of plastic. Sometimes we'll use photosensitive inks. Sometimes we'll use kind of acrylic resins that respond to UV light. Some of those resins and inks are a little bit nasty. They can become a skin sensitizer, and so you have to keep things pretty clean. Make sure you're wearing proper protective equipment. So of course we throw out quite a few gloves and that kind of thing. Lots of paper towel, definitely. Uh, Making sure that waste management is the most important thing when it comes to these types of products. Is how do you handle uncured ink is not great, and so sometimes you have to throw it in the sun to let it cure for a little bit. Um, there are starting to A lot of times in resin printing, we'll wash parts with isopropyl alcohol, which of course you have to handle safely in your production facility, and there's a lot of fire code regulations around that. But then you have to also you can't dump that down the drain, so you have to recycle it when it's full of resin. So having I guess an integrated waste management system for all the types of things that you do is pretty important. Even the bottles that had the resin in them, you really have to dispose of those properly if you're doing things the right way. It's pretty easy to just throw stuff in the garbage and kind of do this, but we're in things for the long term, and frankly, a lot of younger people work here, and they're really concerned about the environment, which is great because when I grew up, it wasn't as much of a concern, but it keeps us honest, and I think we all feel better about operating the right way. Environmentally, from a health and safety standpoint, from a human resources standpoint, when you do things right, you don't really have anything to worry about, is kind of my philosophy. So,
Hmm.
um, but you're never perfect, and there's always areas for improvement also. So,
Absolutely.
yeah,
Continuous improvement, Steve.
yeah, never stops.
So, so if we were to bring this together, if someone is looking to have something 3D printed, what would be your suggestions so that they do so as environmentally friendly as possible?
Sure, the first thing is to say, why do I need this 3D printed? That's number one. If it's a part that you can buy that's been made by someone else, then buy it. Will almost always be cheaper. It'll always be better. One thing, just from a technical thing, I just want to point out. So, injection molded polymers, they're like this. 3D printed polymers are like this. And so, because we're building things layer by layer, so we always get a little bit more weakness on the Z-axis. So, especially with kind of consumer level 3D printing, your parts aren't always going to be stronger anyway. So, if you think it's $2 worth of filament and the part costs $5, you spend 3 hours to make it and it breaks, is it really cheaper? I don't know. So number one, I would say, do you really need to 3D print something? Sorry. The question is, I need something. Number one, do I need that thing? Number two, is 3D printing a way to get it? Maybe. Maybe. But people are often surprised at the cost of 3D printing things. When we did a lot of smaller jobs, our minimum was, $100. Our minimum now is $1,000, just given the level of stuff that we do. So it's really hard for any business to make money doing small little random prints of small parts for the general public. Business to business, and when you have proper designs, yes. I will also say it happens at least 5 or 6 times a week where someone will send us a part to quote, and we really suggest go buy a consumer grade desktop 3D printer for $1,500 and make the part yourself. And after you make 5 parts, you'll have paid for the printer and you'll have the expertise, as opposed to giving us parts that we frankly don't really want to make, that are pretty easy to do. So I will say that although the technology has evolved a lot, and I think anybody with a bit of gumption could buy a printer and figure it out. with all the resources that are available today. There's still an awful lot to learn. And I do caution people that there's some really good desktop 3D printers. There's some really not good ones too. And a lot of times people will buy something maybe for for a lower price point. And then they spend way more time playing with the 3D printer than actually 3D printing. And that is a common thing also.
That's what I can imagine that.
Mm-hmm.
So your questions were, do you really need the thing?
Do you really need the thing? Is 3D printing the best way to do it? What's your budget and how do you want to make this thing? So, there are some things, we do a lot of movie props. People need a movie prop in 3 days. It's a little too complex to CNC machine, or it has to look like gold, or has to have diamonds stuck to it, or what have you. 3D printing is a real good way to make that stuff quickly. There are very often alternatives to 3D printing that may be more cost effective depending on what the part is. We often also get requests for silly things like print me a sphere that's 3 inches in diameter, or print me 10 boxes that are 2 centimeters square. Like 3D printing makes no sense for that. Laser cutting often is something we recommend if there's not a lot of complexity. Sometimes CNC machining out of foam for larger stuff makes more sense. There's always different trade-offs, and one thing that we try very hard not to do here is to put a square peg in a round hole. So if 3D printing is not the right solution, or if we think there might be something better, we'll tell people that, because there's no point in enforcing this technology. There's some things we can do with additive manufacturing that you cannot do other ways. Like, you just can't do it, or it's almost, or it's not effective to do. But those cases tend to be pretty specific and generally in the B2B world.
Okay. As you're talking, I'm reminded of the apple that I saw in your facility. I don't know if that was a movie prop, but it looks like it could have been. But this apple looked exactly like a real life gala apple. I could have taken a bite out of it. The only thing that was off for me was the weight of it. It was a lot heavier than an actual apple would have been. And I thought, wow, that's so cool. Like, the possibilities are endless, but there's so much to think about. And if we're adding on to your list too of like things to think about, what I've heard today, something to ask the 3D printing company is around, what are your waste management practices? Because that's something that's really important around the machines and what you do with it in life, with the resins and the materials, with the water. And you want to make sure you're dealing with a 3D printer that's doing the right thing for the environment. That's
I
what
would
I'm thinking.
add, as well as waste management, the safety practices. Okay.
Okay.
And so safety is really important in manufacturing. Doesn't matter if it's additive manufacturing, subtractive manufacturing, that kind of thing. So if you are working with a provider and you see people, for example, sanding or working on parts that aren't wearing safety glasses, or you see people handling resins without wearing gloves, or you go into a room that just stinks because there's no ventilation, just be cautious and think about who you're dealing with. Now, we all, especially in startup, I mean, you're bootstrapping and you have to do what you have to do to make things work. I've seen 3D printing rooms that used to be bathrooms and closets and those kind of things, and sometimes that's necessary. But if you're dealing with a commercial provider, it's usually a pretty good idea to understand how their work practices are, because that's going to affect the quality of your part and your experience, as well as the environment and the workers that are there.
Yeah, totally. Yeah, thank you for that safety. Ask about safety. Steve, I feel like I've learned a lot in this conversation already. As we close this out, what would be one final piece of advice you would leave our listeners with regarding 3D printing?
Do your research, not on ChatGPT. If you need a part, okay, there's lots of online places you can order one part from. But if you're developing something or you're interested in the technology, go talk to people that actually use the technology every day. There's so much marketing. I don't know what the word I want to use on a podcast is, but there's a lot of fluff and there's a lot of wishful thinking out there, and a lot of bold statements that may or may not be true. So validate those with someone who actually does the work and uses the equipment. And if you're going to make a real commitment, go and see someone. Steph, the reason I invited you to Objects is it's really hard to share what we do. We could have the best website and all the videos in the world, but until you physically visit a place, it's really hard to understand those things. So I encourage people to come and visit us at Objects if you're interested in working with us or want to learn about the technology. But just in general, I think we have this tendency these days to stay behind our screens and everything's done by email and text. And one thing I was told early in my career was like, pick up the phone, man. Pick up the phone and call someone. And I would say further to that, if it's possible, especially if you're in the area, go visit people, get that face-to-face interaction, understand not just the good things, but the challenges that are involved. Because the more you understand how things are produced, the more that you can manage your expectations or manage your development cycle around that. The more information, the better. The more research, the better. But research online only takes you so far.
Agreed. And therefore, to your point, do your research, but don't just use ChatGPT. You won't get all those answers, those real answers through ChatGPT. Thank you, Steve. Thank you for being so honest. Thank you for being a champion for your industry as well. I know you're a leader, and I appreciate you coming on and sharing your wisdom with our listeners.
It's a pleasure, Steph. And I have to say to the people watching this podcast, clearly you have probably interacted with Quantum Lifecycle, but what a resource. What a resource for us to be able to responsibly manage things. Some of the equipment we have weighs like 2,000 pounds and has 40 circuit boards and all kinds of wires and print heads and all these different things that should not be in a landfill and should be recovered. And I'm so thrilled that we're working together. And we constantly cycle our fleet. I have probably 8 more machines that'll be obsolete within a year or two. And I feel now that I have a way to manage that as opposed to, again, just stripping things, trying to sell whatever we can, and then junking the rest of it. It's so good. It's so good to do things right.
Well, thank you, Steve. We are honored to work with you, honestly.
And remember, if you are looking for a partner to help you manage the life cycle of your electronics, we'd love to chat. Head on over to quantumlifecycle.com and contact us. This is a Quantum Lifecycle podcast, and the producer is Sanjay Trivedi. Thank you for being a circular future champion in your company and beyond. Logging off.